Hello and welcome to your fourth homework video on solving absolute value equations. I'm your host, Mrs. Herrera, and today we'll be talking about the absolute value equations worksheet that we gave you in class. I'm going to do problems 2 and 9. Okay, let's start with our first problem. Number 2 says the absolute value of negative 6p is equal to 24. Now remember that absolute value means the distance from 0, and distance cannot be negative. So whenever we plug in for p, we take the positive value when that p value is multiplied by negative 6. Just remember that there are two possible answers when you're doing an absolute value equation in most cases, because your distance can go in a positive direction or the distance can go in a negative direction. Although distance is never negative, it can travel in the negative direction or left on the number line. And then distance could travel in a positive direction or right on the negative line. So most cases, for absolute value equations, you're going to have two possible solutions. Now there are cases where there is an absolute value equation that has only one solution, or there are cases where the absolute value equation has no solutions. But again, most cases there are two solutions for an absolute value. So let's go ahead and split this up. We have negative 6p. The absolute value of negative 6p equals 24, and I'm going to rewrite that into two different equations. So there's a possibility that negative 6p, when I multiply negative 6 times p, that it equals 24. Because remember, if I put 24 into the absolute value, that absolute value would still be 24. Or there's a possibility that negative 6p could equal negative 24. Because I could put negative 24 into this absolute value bracket, but the absolute value would still be positive 24. So then I solve each of these individually. Divide by negative 6, divide by negative 6, and here I get p equals negative 4. Or here I divide by negative 6, I divide by negative 6, p equals positive 4. Now, a lot of people think that it's just going to be always opposite, like 4 or negative 4, or 1/2 or negative 1/2, but that's just not the case. In this situation it was, but whenever we have an addition or subtraction inside the absolute value, our values for p will be different. They will not only be opposite. Okay? So let's try number 9. So here we have 3 times the absolute value of 4m minus 5. And these parentheses here are just kind of help show you that you're multiplying. And that equals 30. So we have 3 times the absolute value of 4m minus 5 equals 30. Well, I have to get the absolute value symbols alone before I can do anything with inside the absolute value. So the very first thing I'm going to do is undo the multiplication of 3 by dividing by 3 on both sides. 3 over 3 is 1, so they cancel each other out. And over here, 30 divided by 3 is 10. So I am left with the absolute value of 4m minus 5 is equal to 10. So now I have my absolute value symbols alone. Inside the absolute value, I have 4m minus 5. I can now split this up into two different equations. So the first possibility is that 4m minus 5, that whole thing, could be equal to 10. Or 4m minus 5 could be equal to negative 10. Remember that if I were to plug in negative 10 in place of 4m minus 5, the absolute value of negative 10 is still 10. And now here I can solve. So I'm going to add 5 on both sides over here. And then I get 4m equals 15. And then I divide by 4. And I get m equals, I could leave it as 15/4. That's fine. Or I could write it as a mixed number. 4 goes into 15 3 times, 3 3/4. And then I have to solve my other option here. So I do the same thing, same process, add 5 to both sides. Here I'm going to get 4m equals -5. And I divide by 4. And I have m equals -5/4. So my options are that m equals either 15/4 or -5/4. If I want, I can check my answers by plugging both in to see that I would get a true statement. That when I plug that in for m, I either get 10 or -10 inside of my absolute value signs. Any questions, always see me or Mr. Daniels, and have a great night.